So we're going to talk about minerals right now. In order for something to be a mineral, it has to have certain properties. It has to be solid, it has to be naturally occurring, and it has to be inorganic. It has to be not living. So I have a few things around my office, and let's see if they're minerals. Oh, look, another dinosaur. So here we have a plastic dinosaur, of course, a brontosaurus. Is this a mineral? No, it is not. Plastic is not naturally occurring. Well, about the bag of croutons. Croutons are solid. They're naturally occurring. Well, maybe not in the crouton form, but, it's made out of natural whole grains. Nope. Organic, not inorganic. It has to be inorganic, not living. Remember that the grains that went into this were certainly living. Well, what about a bottle of water? Water's all natural, isn't it? It's liquid. Therefore, it's not a mineral. So those items are not minerals. So let's look at some examples of things that are minerals. We have quartz here. I have very lovely feldspar. And I have everybody's favorite, mica. Now, why is mica everybody's favorite? Come on, you can admit it. You know why you like it. You like destroying it. You like pulling it apart into its various layers. So the question is, why does mica have this property that we can pull it apart into layers? Well, all three of those minerals are part of the same family or class, what we call silicates. Silicates are all made out of silicon and oxygen, and they can have other things in them as well. But the basic building block is the silicate tetrahedron, this cute little guy right here, a little larger than normal size. So we have a silicon in the middle and 4 oxygens around it. And these guys can hook up in very interesting chemical ways. They can form sheets. And if they form sheets, then where this would naturally break apart would be between the layers, between the sheets. And that's how you get mica. So the reason why mica breaks apart into sheets is because these guys are arranged in sheets. Well, what about the quartz? The quartz is a little bit more irregular in shape. So can you figure out how these guys are arranged? Are they going to be arranged in a nice, simple pattern, or is it going to be very complicated? Well, obviously, it's very complicated because when this thing was broken, it didn't break in a particular way. Because it just took the opportunity to break wherever it could. There wasn't a natural place where it would break easily, like in the mica. If you look at the feldspar, can you figure out something about the way the feldspar breaks? It's flat on the top and bottom, so there's obviously some natural location where the bonds are weaker and it can more easily break apart. So these are examples, as I said, of silicates. There are other important classes of minerals as well. And another important class of minerals are what we call the carbonates. And the carbonates have carbon and oxygen in them. And we find carbonate minerals quite often in rocks in the sea floor or where the sea floor used to be. Because remember, with plate tectonics, everything's always moving. So I have a nice carbonate mineral here. This is calcite. And carbonate minerals can usually be identified by using something called the acid test. So stand back. I'm going to do some science here. So I put a nice fresh scratch on this piece of calcite. Hope you can see that. And I'm going to drop this weak acid on to that fresh scratch. And I don't know if you'll be able to see it. I can certainly see it and hear it. But that's fizzing. It's reacting with the acid. And that's a really good identifier for a carbonate mineral. So we're going to see minerals in several places in this class. And we're definitely going to come back to these guys. These guys are going to be the bad guy. Remember his face. This is the face of doom. We'll come back to him when we talk about volcanoes.